worked with Israelis in the past. We are kind of loud, I know. And it's my third time in a row here. I guess I don't know the volunteers and everyone didn't get fed of me yet, or they were really panicking for not having anyone want to speak here, so they allowed me to come again. And what's going to be interesting this one is I'm going off script completely, and I'm basically telling you that everything I said last year, anyone was in my talk last year? Oh. So, sorry, I was wrong. And this is what the talk is about. So, let's see how this goes. Worst case, I will just flip slide old-fashioned way. Oh, because I'm not on this. Ha! It works. I'll skip this one because Kyle also already mentioned a few things about me. Based on the accent, I wasn't born here. I was born in Israel, and that's where I learned about security at the beginning. 2024, I gave a talk, and I said AI can't reliably fix code vulnerabilities. This is me here. See how I was very confident in what I was saying. Well, that didn't age very well, because since then, AI is everywhere, right? You have AI-generated code going to production in your environment, right? See what AWS, the CEO said, and well, that didn't age very well either. Based on last week, we don't know if it was because of AI, but Cursor and Windsurf just blowing up, pushing out code for you. We know that hackers are using code. We know that Expo, well, if you don't know, Expo, the AI pen testing company, they ranked #1 on HackerOne with their AI. There's no human, there's AI working that. So Aikido just published, I think, this week or last week, Aikido, they have a booth here, that according to surveys that they did, 1 out of 5 incidents come from AI-generated code. 1 out of 5. That's a lot. So if AI can do all this, if AI can help hackers detect, if AI generates the code, if AI breaks the code, it's just fair for AI to also fix the code, right? Whether we can do it or not, that's what I would want them to do. Before we go there, this talk is going to be how AI can help you that, but if you are feared for your job, this is not an AI flashy talk. When I was preparing for this talk and I asked it about, this was earlier this week when AWS was down, I asked it specifically, okay, this link, let's work on it. And as you can see, simple math skills are still missing from AI because August 2025 is in the future. We are only in October 2025. So don't worry. We still have a moment or two until AI can replace us. The real question now, it's not about can AI fix vulnerabilities. I used to ask that. But the fact is, AI can fix vulnerability. The question is, can it do it well? That used to be the question. Now the question is not can. We have to use AI. We cannot move fast enough. But we should not drink from the Kool-Aid and say, oh, we have a magical AI that can do everything. The question is, how can we make it reliable? Why is reliable important? Because if you generate a lot of fixes, and each fix you need to validate if it's true or not, yeah, that doesn't work for you. That won't work for your developers. I didn't ask, any developers in the room? Any developers that care about security in the room? No, that's for. So the fact is that when you give developers a tool that they don't like, aka a tool that came from security, and that tool is not accurate, yeah, good luck with that. So when I gave the talk, it was October of last year, exactly 1 year from tomorrow, and I was so sure of myself because this is what we do. This is our business. We started with zero AI at the beginning, starting in 2022, so there was no Gen AI, and it worked well, and then we added slowly AI. We knew why AI cannot work, and that's why I gave that talk. And then we went back and thought about it a little bit more because we said we have to figure out how to use AI for that. What we learned in that research between October and April is that you can use AI under certain conditions. You need to continuously test it. You need to have real-world data and a lot of that data. I will soon tell you how much information we had. By the way, there will be more detailed slides with a lot of words, and I'm happy to give those to anyone. If you connect me with me later, send on LinkedIn, just tell me why you're reaching out to me. I kind of snob on LinkedIn. I don't accept everyone. And then I'll share the slides with you if you want. Real world data is really important, and human oversight is extremely important. And in the part of building this solution. And what we learned, it's more critical than anything, is learn when AI cannot do something, because AI can always give you an answer, and AI will always give you an answer. So when we went to build this solution, we understood that it needs to start with good data. We were not looking to train a model. If someone here came to learn how to train a model, this is the right session for you. By the way, I'm shocked that you are all here when Jim Manico is giving a talk. The guy actually invented Brakeman, and you came to my talk, so thank you for that. And if you want, you can go to his talk. I'm not offended. But we realized that it needs to start with the data. And what data did we want to collect? For every vulnerability, in every language, and sometimes in every framework, we needed to collect a lot of information in order to be able to fix every vulnerability in every language, in every framework. We needed to make sure that what we build is reliable. So for every vulnerability, we wanted to know everything there is about that vulnerability, what it means, what's the risk, and how to fix it. We wanted to collect a lot of specific instances of that vulnerability. What was interesting is that we learned that you can't just generate vulnerable code and expect that to cover real-world applications. It's perfectly fine and recommended to use synthetic data, but based on that information. We have some very large organizations that would not appreciate us using their data for building this, and we are not doing that. Everything is based on public information or code that we write, but it needs to be real code, not WebGoat. Don't build your solution on WebGoat or Juice Shop. Those are cool for what they need to be. But we needed a lot. So between 50 and 100 examples of bad code. And we need to have matching fixes. If there are none, we need to create those in order to learn to teach how to do that. And of course, we are in the business, and if you want to build it yourself, you're not in the business of finding the problem, you're in the business of fixing the problem. This is what we are doing here. So you need to learn how to read the report of, say, SAST solution. What do they mean? What information they give you on everything, and what is the format? So all of this we needed to collect, and all the data was for every single vulnerability type in every language. And we did that. Initially, when I just started, for us to add a rule took like 2 weeks per person. Those were awesome rules, perfect. But one rule in a week, you can't build a company like that in 2 weeks. So when I was here last year, I explained to people how we took that 2 weeks and reduced it to 2-3 days. But still, it's not fast enough, and AI is running over the world. We needed to move faster. With this idea, we said, okay, if we just to create a single prompt, wow, the font is really small. Sorry, guys. And I'm not reading the slides there, so that's even a problem. Before creating a single rule, just to collect all that data would take 40 to 60 hours. That's not a great idea. And I came to my team and I told them, you want to build something with AI, but seriously, this is going to be slower than what we have today, so where's the value? So the idea was we want to build a reliable system. When I say model everywhere, by the way, or say or write, it's not an AI model. It's model in the sense of model, system, whatever, right? Don't take me to the wrong place. We wanted to make a reliable system, and we wanted to make that reliable system using AI. Kind of awkward, right? AI and reliable. And the team insisted that we can do that. And I told them, okay, if we are going to do that, we need to go somewhere inspirational. Let's figure out a place in the world that has given the world its greatest gift. Guess which country we went to? What's the number one, the best thing in the world? Pizza. So we went to Italy. And we rented an Airbnb outside of Rome. Everyone was sitting there, and we were trying to figure out how to solve the problem. And we came out with AI Pacino. Mind you, ChatGPT got the information. We are a company, the name is Mob. We are doing this, give us a name. Came up with AI Pacino. And what AI Pacino helps us is basically put system and automation on this process. Okay? So AI Pacino collected a lot of information, public information from the web about what is cross-site scripting. Why should we care about it? What's so special about it with Java? Give me good example, give me bad example. Collect as much information as you can. That was step one, publicly available information. Step two, collect a lot of vulnerable code. And that wasn't easy, but we built a solution that can help us. Currently, we have in our database over 1.6 million code samples, vulnerable code samples. And then match it with fixes. That was more challenging, but let's put that aside. And take all that, use your fancy Claude under the hood, and create a prompt for us. Save us all that time, that initial time that collect the information and generate the first prompt. And then run the prompt. And generated some fixes for our developers, for our security experts to check, because I don't trust you, Pacino. So we did all the heavy lifting at the beginning, and then people like you needed to look at fixes and say, this fix is good. This fix isn't good. If it's not good, I'll tweak it a little bit, and I'll try again. So we took off all, wait, Kyle, I didn't finish. The slide is still loaded.
I just wanted to get the Al Pacino.
Oh, because you can run?
So
there is later another. But it's AI Pacino.
Yeah.
I chose the font that will show that it's I and not L. It was hard to find that font. But the idea is to do that and then check again. And run it again, and run it again. We got to a process where up to 10 iterations, between 5 and 10 iterations usually, we got a prompt that was really, really good. And then we can push it out to production. That took the 2-3 days down to 6 to 8 hours, which means that a team of 3 people can ship 60 to 100 fixes, rule fixes per month. And that's a great leap from where we were before. And those fixes are good. They are not deterministic in the sense of every fix runs the same way, but it's really, really close to that. And it's not, so if you want to introduce something like that, you need to worry about the fact that your users, like the guy there that is already tired from me talking, will not appreciate a security tool that gives them different things every time. They will use it for writing code, not for fixing code. Why is that important? The deterministic, the doing it, let's say conservatively, let's say do it with cautious. We realize that before we do anything we need to do false positive detection. And if you think about the first time, Kyle maybe was around, Matthias was around, Matthias was used to work in 45. So the first time security came and gave SaaS report to developers, that's the first time they lost trust, developers, because of all those false positives, right? Now imagine if they hated that, how much they will love the fact that you're fixing something that was never broken in the first place. So I will be like, hey, I fixed your code. Well, thank you, the code was not broken. The only thing that can ruin the trust more is, hey, I fixed your code. No, you broke my code that was good in the first place. So before we do anything, what we learn is we need to make sure that the thing that is reported to us is not vulnerable. With all due respect to all the SaaS vendors in the world, and I'm a pro SaaS guy, that technology is flawed in a way that it just limitation in technology. Maybe James will say something else if he goes to his booth later because they have a magical SaaS. But by definition, it generates a lot of noise, right? So we wanted to clear that noise. We wanted to make sure that we are not wasting the developer time in reviewing a fix for something that was not broken in the first place. Sounds fair, right? Think about it. If you fix false positive, you either waste the developer's time on reviewing something that was not broken, or you broke your code, their code. So into Pacino, what we added was the first time it does, it generates a prompt, and that prompt will look at the code and will say, yes, it's a true positive. No, it's a false positive, and this is why. Or, I don't know everything. If it's I don't know, it's also good for us, we will review it. Us, the team that built the machine, needs to review it and tune it all the time. Okay, but it's very important not to fix something that is not true positive. This is where you start. The idea was to know more hearing those complaints. As developers, they will complain. I was a developer, so I'm allowed to see that.
So it sounds like you want to reduce false positives. Like you want to drive out of those two numbers. That's the one you want to drive closer to zero.
Yes, well, I want to save developers time, and I want to help organization be secure. Let me take it. I want to help organization secure their code. If they waste time on false positive, it takes them away from securing their code and doing anything else. So I want to first remove false positives. My goal is to make sure that the code that is out is secure.
Do you make developers more efficient by saying, don't worry about security, we'll come tell you how to fix it later. You worry about delivering features fast, and we'll fix security later.
That's my pitch, basically, right? Do people believe me? Not necessarily. But
Okay. So me writing some tools, one of the good experiences we have is to have a limited democratization of tool writing. So you have like architectural things that, because all of this is not limited to security code things. You could have teams that refactor, they want to use certain frameworks.
so
Issuing them the capability to participate in tool construction also.
if you build something in-house, you can do that, right? For us, I need to add those fixed rules. If you have a special rule that finds something that I never saw before, I need to add a rule to fix it. Do you want to fix it in a certain way? You know, you guys are big enough, pay me, I'll build it for you. But the way that, if you're building such a solution that allows prompts to change code, you're opening yourself to prompt injection also. So I cannot allow you, as a user, to use my commercial offering to write your own code rules, right? I will write it for you. Okay? So this was a false positive. Now, for those who actually read the abstract, I said that this will be a blueprint. So I'm going to get more technical now, and we'll see how much time we have for everything. The entire system is based on a two-prompt architecture. Like I said, right, we have the false positive and we have the fixed generation. Fixed generation will not start before false positive. They are separated but very codependent on each other. Well, fixed generation is dependent on false positive. Each of those is constructed from system prompt and user prompt. And the reason is system prompt basically defines the policy on, when I say system prompt is for every single vulnerability type in language in framework. So I will have a system prompt on how to fix SQL injection in Java Spring Boot, for example, okay? And I will have a user prompt for that. So the system prompt, and I'll show more details how it is, basically gives you the policy, and user prompt gives you the instance and all the information. The user prompt will be dynamically created every code that is being evaluated now. And the output for the false positive will be, as I said, true positive, false positive, oh, I don't know. But if it says something, it also needs to give you the reasoning, because if you are adopting my solution, for example, and I tell you, no, these are false positive, someone on the security side should say, why? Tell me why you think it's false positive, right? Because do you trust developers when they say this is false positive? No, you validate them. Would you trust a solution that actually uses AI for that? No, you need to get the reasoning. On the fixed side, again, you have the system prompt and the user prompt, where the user prompt tells you how to fix it properly with this specific code. And the output, what is also important is that you cannot expect, and you shouldn't allow AI to make huge changes, because it's AI. It needs to be the minimal change. Our goal is not to make your product architecturally better. Our goal is to take what your developers would do it faster and better, consistently, right? Most application security vulnerabilities are fixed, if they are fixed, by developers by changing a few lines of code, no more than that. They are not going to re-architect their environment because they have SQL injections. So the separations of the policy on one hand and the instance is important for the scalability of this, right? I don't need to rewrite everything every time. Let's look a little bit about the information. If people are not aware with the system and user prompts, that's like a high-level explanation of the roles. But in our case, one explains the, wow, it's really hard. If I was without glasses, I wouldn't see anything. Define behavior rules, and then you need to provide the specific instance. I'll jump to, the idea is just as an analogy, the system gives you the frame of behavior, and the user is the instance of work, right? It gives you the guardrails for the user prompt, the system prompt. I'll have one, I don't think I will have time to show all of them, but again, I will gladly send it later. This is the structure that we have for a prompt. Every prompt can be a few hundreds lines of code sometimes. It's generated automatically, and I'll explain soon how it's being done. But yes, you do need to tell it, you are a senior security analyst. You have deep expertise in fixing SQL injection in Java. Your goal is to provide analysis on potential false positive, right? What you need to do is very simple. Tell me if it's true positive, if it's false positive, and if you don't know. And this is how you define it. And we give it examples, and we give it set of decisions. And at the end, I want to get a JSON structured that I can use automatically in the next step. That builds just a reliable decision tree for the user prompt for the false positive. The user prompt is similar. It's also a security code analyst with expertise. It gets its instructions from the system prompt. And this is where it's more dynamic because it also has the language. It also has the code, the specific sample, and it looks at it, and it applies the logic that was provided to it. And at the end, it will give that information. Again, the information will be, this is a false positive because obviously it's just name of a parameter password. It's not a password like every SaaS tool usually say. Or it's not SQL injection because I see here that the data came from a trusted source or it was sanitized already. We give all that information, okay? And we vet that. So I'll skip the other two because of time. And I want to talk about how all those prompts become a multi-stage approach, right? So the first step, as we mentioned, false positive detection. We generate the system and user prompts to detect the false positive. And if it's true, great, we move to fix. If it's false, everyone are happy. Developers are happy when you tell them, you don't need to do anything. This was crap, and this is why. And we have people that trust to the level that they automated that back through their tool and say, if mob said it's false positive, it's false positive. You don't need to do anything. If it's unknown, that's a problem. That's where our system failed. We do not provide a fix. We will go and look at it. Okay? This is where human in the loop is required. If it is true, naturally you want to generate a fix. We do it also very cautiously, very limited, and I'll explain where some pitfalls that AI showed you. And then the code that you generate needs to be validated. When I say validated, I am not going to compile the code because that takes a lot of time. Everything needs to happen fast, right? You may have a large application with hundreds of thousands of lines of code or even more. You cannot compile it for every fix. It doesn't work. But you can do syntactic check. You can check formatting. You can check style. And we do that. And then if everything works, we provide the fix back to the user. This is where if you build such a solution, you can say, okay, I will commit it directly. I will open a Jira ticket for the user, or I will give it back to their ID. Whatever works in your organization, this is how you want it. But the underlying technology is what's important. This multi-stage with checks and balances is what helps you prevent the noise and make sure that the fixes that you provide are secure. Okay? Be very careful when you're going to build this. So if I'm summarizing what I presented to you, the system of the false positive, it defines the validation logic. And what it gives you is it's a standard way of classifying an issue. No, you as a user, you're not seeing anything from it. The false positive user prompt takes that with the evidence and makes a decision for that case. Then if the user prompt says, yes, it's true positive, then the system prompt of the fix gets in, defines how to fix, gives the fix logic, and the user prompt of the fix takes that fix logic, combines it with the code, and generates a fix. After all this, it's being tested, and then it will generate a fix that is highly accurate and very predictable. If you have 100 instances of that problem, you will get very similar fixes. It's still AI, so you won't get perfect. I want to show you the reality now, because, hey, I think I told you earlier, right? My investors may not be happy that I'm sharing everything that we do. I'm also sharing where it fails. So we went with Pacino, ate a lot of pizzas, drank a lot of beer and wine in Rome, and we built it, and then we went home and started to test, and oh my God, the success rate of the first prompt was 10 to 15%. Very underwhelming. But still, it saved us a lot of time. So the initial prompt was generated with Pacino. The initial test was generated with Pacino, but then we needed someone to do manual review. So eyes on the screen, hands on keyboards, look at the fix, say, this is wrong, obviously. Okay, I'll change the prompt a little bit, and I'll try it again. Pacino was all about operationalize that generation of prompt. We didn't expect it to have prompts that work out of the bat. Actually, we were counting on that it won't work because otherwise it will be very easy for people to mimic what we do and do that on their own. So it does require human in the loop and work faster. And that's why for fixing a single vulnerability, for generating that false positive prompt and fixed prompt, that combination of 4, it still takes time, about 6 to 8 hours. As I mentioned, 5 to 10 iterations. But you need to put that effort. If you just wrap Claude and tell Claude, hey, checkmark said there is SQL injection here, please fix it for me, it won't last long. Developers won't use it, and then you just wasted time or money even. So let's show you, now you have. You see, this is better.
Yeah, that is
Yeah. So I want to show you why the iteration is needed and why you can't just give it for developers and not necessarily every AppSec person. So this is basically an example, a short example of vulnerable code. There is header manipulation here in the code. And the prompt, the initial prompt was already 487 lines long. System prompt, user code, all of it together 487. And Pacino did this. So basically it added, I can't read on that side, it added the text escape util, and it called it, and basically to escape the code. So it escaped the field that came from the outside, the file extension, okay? It escaped, it added it did the import, and it also escaped the header here, the file name in the header. Yeah?
You can still manipulate the file name.
You can what?
You can still manipulate the file name.
You can't see?
it.
You can, okay.
Still manipulate the file name, he said.
Yes. Why?
Because all it did is do some sanitization, but is it valid input though?
So it did basically, you're right, it did the HTML escaping. It didn't do the header escaping. It's basically incomplete sanitization. Now, I bet you 10 to 1 that if you give that fix to your developer, they will say, okay, cool. And I will bet you 5 to 1 that at least half of the people here in this conference, 250 people sold out LASCON, will not know that there is a problem. So you have a solution, and by the way, we know because we see some solutions based on AI generating fixes. You have solutions that generate fixes that are accepted and not necessarily detected by their own SaaS tools with fixes that are not good enough. So that human in the loop, no matter how far you get, someone that actually knows how to read this stuff needs to review the fix. And as long as those fixes are predictable, meaning the next 10 instances I will send will generate the same fix, the same logic, we're golden. You review one, you use it all the time. Okay? So what we did, basically, we said, okay, everything that we told you, those 487 lines, great, now add this. This is exactly how I want you to sanitize. It still collects all the context. It's still generating the code. At the end, the sanitization that it will use, instead of text escape utils, we'll use this. So you can say, hey, but it's not AI remediation. It's a mix. AI does it. It's just part of the instructions that the AI gets.
So do you actually tell it in the prompt, here's some additional stuff, as opposed to poking it into the output?
Yes.
Okay.
I don't want to manipulate the output after, because then I'm risking of learning a lot of how AI generates it and the context. I may miss some things. And it worked this way, so why not? Okay, so this was April, May. Now what we learn is, don't believe Eitan when he says something. Question yourself all the time. The technology advances so much, so let's see if we can use it and leverage it and to make it even better. Now, what I didn't mention before, and no one asked, why don't we use AI to check the fixes that are generated and tell us if the fixes are good or not? We tried, it didn't go well. So we gave that up. Human needed to be involved on the first evaluation. So Pacino was young, few months old, and we were already looking for a replacement. No, we were looking to see, and it was, by the way, it was great improvement for us, right? Moving from 2-3 days per rule to 6 to 8 hours per rule. That's great. But can we make it even faster? And when we thought, okay, I have some AI groupies in my team, let's see what we can do. We realized that already the initial prompt that we generate, by the way, Pacino under the hood currently uses Claude. In the past, it uses OpenAI, moved to Mixtral, moved to Claude. Now we are Claude 4 there. So it generates the initial prompt. Now, instead of taking that prompt and running it on the code and generating fixes and having a person reviewing them, said, let's take that prompt and pass it to another model, not the fix, the prompt itself. And currently the team is using Codex for that, but sorry, picture. I usually have really bad pictures. So instead of validating it, we pass it to another model. Of course, you cannot use the same model. It just doesn't make sense. And told, critic it. This is what you are. This is what you need to do. Tell us where you are wrong and adjust it. And then we let the two fight. Once they finish fighting, we get a prompt. And that prompt, then we go to that step of testing it on new code. We are not going to test it on the same code that was used to generate the prompt, obviously, on new samples, and see how it works. And there is where the AI and human interaction happens. Human is still in the loop. A human being is actually reviewing the fixes. No, we still couldn't figure out a way to get AI to check the fixes and trust it. So a human reviews it. And if something is wrong, they use Codex again and tell Codex, hey, this is the problem. Help me generate a newer prompt. It generates a new prompt. We feed it again. We run it again. This allows us to take down from 6 to 8 hours to 2 to 3 hours. So more than half of the time was saved. If you are going to explore with this, I strongly suggest involving AI in every step. Make sure that humans that know what they are doing review the code and make the adjustment. And I'm saying human that knows what they're doing needs to be a security expert. Now, it may seem not very fulfilling to look at code fixes and say, are they good or not? Day in, day out, hours. Especially if you don't like puzzles, right? For our perspective, we help secure the world, this kind of noble cause, so it is fulfilling, but if I couldn't work in that job. I would not be able to look at the screen and see all those fixes and say, oh, it's wrong here. Yes, this is how it's supposed to do. Let me tweak a little bit. There are certain type of people that can do that. Oh, saying all that, even if after all this effort of system prompts, user prompt, system prompt, user prompt, and adjustments and fixes, AI will still surprise you. AI will still fail you. AI will still do things that, why the hell did it do this? We saw that. We experienced it, and I'm here to share what we saw and how we mitigated it, because every time it happened, we found a way to solve it. The first one I already talked, so I'm skipping it, but the second one, we had a fix for a vulnerability in the YAML file, something about, I think, the pinning in the GitHub Actions, and the AI fix deleted half of the file. So there was a problem on certain line, you could fix that, it deleted half of the file. And we didn't know this because we didn't have those constraints. And Robert pinged me on Slack and told me, Eitan, what the fuck happened now? You deleted half of the file. Tell him, oops, sorry. And then you learn, okay, it's not enough that you need to give AI the minimal amount of code that is required to make a change. Sometimes that minimal amount of code will be the entire file or more than one file. But if you can limit it, limit it. If you know, when you wrote those rules, if you know what to expect, and you should know, if I expect to have 10 lines change, 4 lines change, 40 lines change, include that in the checks. At the end, I would rather not bring you a fix versus give you a fix that is wrong. Remember that. That's the most important things. If you are building it or if you're going to evaluate tools, it's not about their coverage, it's about their accuracy. If I give a developer a fix that breaks his code, that becomes a shelfware after that. Second thing that breaks, another issue. AI fixed the problem and removed the return statement. So the problem was in the return statement. In the fix, it didn't include return. I mean, seriously, how? And then developers are also even more annoyed because that's an easy thing that the tool should have known. Again, you add it to the prompt, to the instructions. You tell it, make sure to preserve the logic. And again, if someone wants a slide later, I have that explanation in the prompt, as far as I recall. And this is also interesting. As I mentioned, if you have a fix that needs to run many times, and every time it generates different fix, again, you will lose trust. Sometimes you need to enrich the prompt with exactly how I want you to fix it, like I showed earlier. Don't think. We have now, side topic, we added integration into Cursor and all those. When we provide a fix to Cursor or to Copilot or whatever, we very strictly tell it, don't even think about trying to change anything. This is the patch file, you apply it as is. Because otherwise the AI is eager to please, it will change whatever it thinks is wrong. Make sure that it does only what you want it to do. Okay? Be proactive with the mitigation. If it fails, if someone tells you something is wrong, this is the moment that you drop everything and you fix it, because one person complained, there are 10 others that didn't complain. Fix it quickly before they see it. Okay? Make sure to build right. Huh?
10-minute warning.
10 minutes warning. Okay. There are other reasons, and Hector, this is what we talked about earlier. There is a reason why all the AI models went to a consumption model, right? Models. There is a reason why they're evaluated so much. Because token costs money. It can be very, very expensive. So think about ways where sometimes you don't need to use AI. You can use something else. For example, you have math random that is used for security. Come on. Use crypto, get random value. It's a very deterministic code change. Easy one to do. Sometimes it's a little bit more than that. So for example, XXC, in order to fix it, you have a factory set field, true, false, stuff like that, and you get rid of it. Those sometimes will be easier even to generate, faster to generate that fix versus generating an AI fix and testing it and all. But it doesn't end there. If you have a fix that takes a lot of time, it will take a lot of tokens, and also developers won't be happy. If you have 100 fixes that you need to generate, and each one of them takes 30 seconds, developers will kill the task. Okay, so figure out. And the most important about money, if you have 100,000 unending loop, I forgot that loop condition, unchecked loop condition, for example, the checkmarks like to report. If you have 100,000 of those, that can be expensive to run with AI. So if it's 2 cents per fix with AI, and you have 10,000 of those, that's $200. Now, $200 is not a lot for 100,000 fixes. I give you that. But I also will tell you that the 100,000 fixes that you gave to that developers, it will ignore them on the first day. And you run them again after the pipeline, the next one, and the next one, and the next one, until they start to clean them out. Now, you can't just keep the fix forever because the code changed also, so you do need to generate the fix again. If you have those, sometimes it's worth to even invest a week in generating a static deterministic fix that costs nothing to run, just CPU. And then it will generate all the time the same fix. You have a question?
I was going to ask, when do you know? So in other words, I look at this, and what branch do I take that says, I use the advice I get from my development tool or static thing, versus you got to go AI?
So first of all, if you are building it in your house, right, you can look at the dashboard and see how many instances of certain issue you have. So the last one is easy, right? It's too expensive to run it with AI every time. Let me try to figure out how to build it deterministically. If I can, great. The others, when you look at the problem, you need to imagine how you would do it. Anyway, you want to imagine how you would do it because you don't want to be surprised with the AI. So you imagine how the fix should look and figure out the way to do it. Okay? I will try to go fast. So this is actually to your question, right? We figured out actually more than 2 options. We figured out 3 options. The first option, algorithmic, you just write an algorithm on how to fix it. Think about SemGrep, think about linters. Those are algorithms to find problems. They also fix. SemGrep have from day one, they had the regex fix kind of thing. So if you can do it this way, cheapest. It's hard to grow coverage. As I told you, it took us 2 to 3 days as when we got the most advanced on average to generate a fix. And it's also limited in the things that you can fix with it. We assume, and the numbers are not scientific, we assume about 45% of the things can be fixed. Good thing is most of them are very common. So injections as long as not. The one-shot prompt is what I described to you now. So it takes you time to build that prompt, but once you build that prompt, you run it, it works. Okay, no one cares how many prompts you needed before to fix. In runtime, well, I mean, it's quick to implement, it's not necessarily consistent, and it can be expensive at scale. The last one that we are currently only experimenting with because there is a diminishing return on investment there. Basically, you have a prompt to answer a bunch of questions and collect context that will later be used to decide which prompt to run next with more information, and so on until you have all the information that you need in order to fix. This is crazy expensive, we see, although there are going to be certain cases where we will use that because we cannot get better in that. We will never use it if we have 100,000 fixes to generate with it, because then I will need way more investors. The strategy, to your question, we look at the issue. If we know we can fix it deterministically in a matter of hours, up to a day, we will do that. Otherwise, we go with AI. Then, if we see that we see reports with a lot of those, and I think in July, you should have seen the faces of Jonathan, my CTO, and mine, when we got a surprising bill from AWS Bedrock. And that was, oh shit, moment. And I told him, yeah, no, I don't agree. Figure it out. So there were rules that we figured out that, oh, we could write them easily with this. And we found ways to cache AI and all that. But you don't want to be surprised. I remember speaking with a customer. They were going to buy our solution for all their developers, and he told me, I just got a $100,000 bill from AWS. I lost half of the budget. So, okay. So this is how, and this is why the last one is, in theoretical, if I work in a university, I would do that. But in the real world, it doesn't work. So, how much time do I have? Like 5 minutes? 4 minutes? Okay, I'll skip this one. Things that we learn, right? I do have some AI fanboys in my club. And right, they want to believe that AI can do everything without much guidance. They want to believe that the most well-trained LLMs or the very specific SLMs can handle everything. What we actually learn is false positive is where you start, right? Otherwise, first of all, it's the biggest pain for your buck also, because you tell developers 60, 70% of the things you don't need to do. Everyone are happy. The backlog crashed. You didn't need to do anything. But then if you didn't do that, you actually cause everything to be worse. Validation is always important, and you cannot just trust the AI. You need to have that human in the loop. You don't need to have that human in the loop on every fix, because then the solution is not usable. If a developer, just here's a secret, because I didn't think about it 3-4 years ago when I started. I thought, oh, I'm giving a solution that developers will love, everyone will love our companies, because we take the thing that they hate most and we will do it for them. Well, guess what? If the developers hate something, they just don't do it. So I didn't save them money. I didn't save them time. They never did it. I actually gave them work, because now they need to review the fixes that I gave for something that they wouldn't care initially. So one more thing that I didn't mention earlier, when you do the prompt, don't search for the perfect prompt from day one. Don't waste too much time on the perfect initial prompt. Run it, you'll see the problem, iterate on it. Just working on the perfect prompt from day one will take you more than doing all those iterations. Telling the AI what not to do is as important as how to fix something. Key takeaways, and this is the blueprint summary of what I mentioned. Basically, I mentioned validation is non-negotiable, right? It generates something, you need to validate. You need to validate until you have a prompt that is good enough. What is good enough? It's a question. GitHub, in their opinion, they scanned their rules on the top 10,000, when they just launched their GitHub Autofix, on the top 10,000 open source projects. And if at least 70% of the fixes get merged with little to no edits, that's good enough for them. That means that 1/3 of their fixes that they generate goes to trash, and the other ones, you need to review all of them. You don't know necessarily. Many of them you need to tweak. Now, if a developer didn't do anything before, will he do that? No. I spoke, sorry, GitHub folks, friends, from the recording, not anyone in the room. I spoke with 2 very large organizations that have GitHub Advanced Security. They sort of like it. They have Copilot, which means they have GitHub Autofix for free. I asked them, okay, tell me how your developers are using it. What's the reaction? They said they don't use it. Why? Because it fixes things that are not broken. Because it fixes things in the wrong place. You get a developer a fix that they need to waste much time on it, they will not use it, it becomes a shelfware. Okay, so validate, have that human in the loop. It's important. We are not fully replaced by AI yet. Maybe next year I give a talk and I will say, oh shit, I was wrong. Oops, I did it again. The most important thing, let's stop just finding things, let's fix, because in the pace of AI now, you just saw at the beginning that surveys that says 20% of the vulnerabilities today, the breaches came from AI code, and we are just starting, so we know that next year it will be 70%. And cool. I try not to talk about mob too much like I usually do, and this time it's with good reason, because we have a booth here. If you go out the door, take left. Come talk to us. If you want to hear about other cool vendors. You have another one just straight here, but after you come to mine, go to James on his booth next. Dry run. Okay? I would love to connect. If you have any questions, I think we have about a minute. Any questions?
Did you get it working well for multi-file fixes?
Yes.
Yeah?
Yes. It was surprising, actually. Sometimes, not only that, we had a case where the AI suggested that we needed to add a parameter to a method in order to do something. It changed the signature of the method in another file. It took care of everything. Those are one of those fixes that cost a lot of money, though, because the token size is bigger and it takes longer. But yeah.
In your multi-prompt system, do you ever face challenges in terms of handling context or conversation history? Because the larger the prompt gets, sometimes the model loses focus.
Yeah. So the question was, I don't know if it's recorded, but it doesn't matter. The question was, when we have those multi-prompts, at the end, if the context is getting too big, AI starts to lose it. I guess you all experienced that. When ChatGPT at the beginning was good, oh, you forgot what I said earlier. We put a lot of effort on minimizing the amount of information that we collect from the code, not because we are for code sharing, because of that. If we give a lot of information, first, it tries to do things that we didn't ask it, but also the context. We may exceed the context window, so we limit it. And because we limit, we don't see it. When we forget, we do see it. Okay? Any other questions?
You started with it was 10 to 15% effective at the
Yeah.
beginning. Where has it landed so far?
Not the first prompt. When the prompt gets to, after that 5 to 10 iterations, and now 2 to 3 iterations, we get to the 70, 90.
Ah, okay.
Yeah. And the most important thing is not about that percentage. It's about knowing when it fails. So if I recently had a fix, I was looking at a report from a customer or prospect, and I saw that we didn't fix SQL injection in JavaScript. And I said, well, this is where we started. Come on, we know how to do that. And the problem there, and we don't hide anything. We showed you what we fixed. We showed you what false positive. We showed you what we didn't fix, what's remaining. And the problem there was that the SAS scanner reported the database name is tainted. And we never thought about that option. So the rule that we designed couldn't fix that, and the AI followed the rules. It didn't know how to fix, so it didn't fix it.
Yeah.
Again, it's important not to let the AI go willy-nilly and fix on their own. Okay? Thank you, everyone.